So yesterday, we were just kind of leading up to actually completing the square. The steps that we took in the homework, the processes that we went through, that's all going to be worked into actually completing the square. So there's going to be a lot of it that's familiar, but the beginning part's going to be different. And so essentially what it is this really still solving equations using the square root property, the same stuff that we were doing yesterday. However, yesterday, the left-hand side of your equation was already set up for you. It was already a binomial square. It's almost like taking a normal completing the square problem and going about halfway through. That's where we started yesterday. So now we're going to go all the way to the beginning and turn them into problems that you did yesterday. Okay. So here are all the steps. First step is you're going to move the constant term to the other side of the x squared and x term. And it could be other variables. I mean, it could be y's, it could be z's, it could be a's, whatever. But you want to get, so instead, again, think back to when we did quadratics before, we always made one side 0. That is not happening here at all. We're doing actually just the opposite. We're moving all the plain numbers to the right, because usually it'll be the right, and then the left will have the x squared and the x term. Those will stay put. Now this next step is really important because sometimes it's already done for you, sometimes it's not. And so you have to be careful. And whether you want to asterisk it, highlight it, something. This step number 2 is really, really important. Okay. If the coefficient on the x squared term isn't a 1, so sometimes it's going to be a 1 and you won't have to worry about this. But a lot of times it's not going to be a 1. So what you want to do is make it, you need to turn it into a 1, which means you have to divide everything by whatever that coefficient is. So if it's a 4x squared, then you're going to divide everything by 4. If it's a 7x squared, you can divide everything by 7. Whatever it is, you got to get x squared just to be x squared. And again, if it's already x squared, 1x squared, then you're good. You don't have to worry about this step. And sometimes that's going to happen. And sometimes that happened yesterday, but not always. Like I said, be sure to highlight this or asterisk it or something, because oftentimes when you guys are completing the square, we forget about this, and that kind of screws everything up. Okay, so make sure you think about that at least and check to see if that needs to be done. Like I said, it doesn't always need to be done. Now we're going to do the part yesterday where we found c, where we took that middle term coefficient divided by 2 and squaring it. That's when we found c yesterday. That's what this is. Okay, that's what the third step is. Divide the x terms coefficient by 2 and square it. This is when we found c yesterday. Okay, that's what that step is. Now, yesterday, we didn't have any equations when we were finding c. It was just an expression. Today, it's going to be an equation. So when we find c and we add it in there so that we have the x squared term, the x term, and then the constant, we can't just add it to the one side. We have to add both sides. So whatever that c is, it gets added to both sides of the equation. That way, we don't change the value of anything. We're doing the same thing to both sides. So once we've done that, essentially what we've done is we've turned the left-hand side into a binomial square, because that's what that c does. So that left-hand side is a binomial square, and then it's just a matter of solving using the square root property like we did yesterday. So essentially, all these first 4 steps were done for us yesterday in the first group of problems, and then we did number 5. Today we're going to have to do these other 4 steps first. All right, here is our first example. X squared plus 10x plus 24 equals 0. Now, I know I used this problem because it has nice, easy solutions, and I realize that this problem can be solved without using completing the square. But I want to show you with numbers that are relatively nice, how this is going to work. First of all, the thing that I noticed right away, and you should get in the habit of doing this, is that this x squared doesn't have a coefficient in front of it. Meaning there's a 1. We understand there to be a 1. So that second step or third step, I don't remember which one. I think it was the second step, where I said highlight that, don't forget about that. Well, that one is done for us already. So we're not going to have to divide everything by some number that's in front of the x squared. So that's a good thing. Okay, so our first move then is looking at your steps. What is my first move going to be? Move the 24. Okay, so when it goes to the other side, it becomes negative. Okay, so we're just going to move that. And now notice here, I left a little space. This is where the c is going to go. Okay, so that's why I left that space there. Now again, we talked about this. We should check, make sure there's not a number that we have to divide through. If this was a 2, for example, I'd have to divide everything by 2 first before you could do anything else. But it's not, so we're good. All right. So go ahead and find C. You guys did that yesterday. So just ignore this minus 24 for now. Go ahead and find the C value and put it in there. Remind me how to find C. What do you do?
Divide by 2.
Divide what by 2?
B.
Which is, in this problem?
10.
10. Divide 10 by 2 and then square it. Okay, right. So now I write this to the side. I like to write this off to the side because it's still part of the work. I still want you to show it. I know you can do 10 divided by 2 in your head. But remember, we're going to need 10 divided by 2 to turn it into a binomial square anyway. Okay, so what does this equal? 25. Okay. So once we find C, we add it to both sides. So one spot's going to be here, and then I'm going to add it over here as well. Okay? You just have to be sure that you add it to both sides. You can't just do it to one, because then that changes the whole problem. Okay? If we did our math right, what should happen is this is now a binomial square. And so we can check that. Okay, what is the square root of x squared? X. What is the square root of 25? Multiply those together times 2. Do I get 10x? X times 5 times 2. Yeah. So I forced this to be a binomial square. And then, of course, what is this over here? 1. So what we've done, this is completing that. We completed the square. We turned what was here into a binomial square. And so now we rewrite it. Okay. The quantity x plus 5, again, that number we got before we squared it, equals 1. Now, if this would have been a minus, then this would be a minus. So, essentially what we did is we created a problem that you worked on yesterday. Right? It would have just said 1. It wouldn't have said this, though, right? Because that was what your problem looked like. Then we changed it to a binomial square. Now we square root property, use square root property, and solve. So go ahead and finish it. Square root property means we're just taking the square root of both sides. Don't forget the plus or minus. Okay, the squaring and square rooting cancel. So I have x plus 5 equals plus or minus 1 because the square root of 1 is 1. Subtract the 5 over. And so I've got negative 4 and negative 6. How many had that? Very good. Okay. Now, again, this problem, I chose this problem because the numbers turned out nice. For our first crack at it, I thought we should do that. Now, a lot of the times with completing the square, they won't turn out so nice. For example, this one. This one's not going to turn out so nice.
What was the answer again?
Negative 4, negative 6. What's kind of your tip off that says this is probably going to be a little rougher? Yeah. The 3. Yeah, the 3 right here is telling me this problem's not going to be as nice. Okay, it's still not horrible. But what that tells me is that at some point I'm going to have to divide everything by 3. And the thing about completing the square that typically you guys don't like that didn't happen in the last problem, that is going to happen in this problem, is we're going to introduce fractions in a lot of places. You know, we've talked a lot about trying to get rid of fractions in our life and work with non-fractions. Well, completing the square, one of the reasons that completing the square can be frustrating is that you introduce fractions that weren't already there. And so it's not usually a preferred method for solving, but sometimes it's the only way. All right, so that being said, the first thing I'm going to do is what? What am I going to do the first?
5/3.
Move that -8. Not yet. Move that -8. Okay, so when it's, and again, I created that space there because I know that I'm going to have to be adding in from minus, this becomes plus. Okay, and so now I'm going to have to divide by 3. And please, please, please do not convert it to decimals unless they come out exact. Obviously, in this problem, they do not. So when I divide everything by 3, 10/3 does not come out even. That's a repeating decimal. So it needs to say 10/3. There's no reason to change it to 3 1/3. Leave it as an improper fraction. Same with 8/3. There's no reason to change it. Just leave it like that. And of course, 3 divided by 3 is 1. So I really don't need to have that there. Okay? But just so you guys can see, the whole point, again, is before we can do completing the square, this has to be a 1x squared. So that's what we've done. Okay, so once we have gotten the constant to the other side, once we've divided the coefficient that's in front of x squared, now we can find our c value. Okay, now I'm going to have to take 10/3 and divide it by 2. What's another way with fractions that we could say that? Instead of 10/3 divided by 2, what could we say? Yeah, Ricky? 10/3 times 1/2, yeah. That might make this problem a little bit easier for us, okay? And we can do both, right? If we weren't sure, we could just say this is 10/3 times 1/2. Keep, change, flip. Right? Those are the same thing. Now, if you're reaching for your calculator and you're plugging it in anyway, then okay. But what I would do first, if it was me and I'm me, I would cross cancel. 2 goes into 10 5 times. Because I know that I'm going to have to square these numbers. And if I have the smallest numbers possible, squaring those numbers is going to be a little nicer. Okay. So in this case, I've got a 5 that I'm going to square, and I've got a 3 that I'm going to square. So what does that all equal? 25/9. And that's reduced. Okay. Again, this is my C. That's what's going to go here. Okay. And then, of course, it's going to have to go there too. Now, I know a lot of you are still getting used to your graphing calculator, but it does do fractions. Okay, for those of you who like your baby calculator better because it does fractions, your graphing calculator does fractions. Okay, so if you need help finding that, I will be happy to show you. Anyway, so here's where we're at. Going to add that 25/9 in. So right, there's a lot of fractional arithmetic that we got to deal with. And so we can do that. First off, I force this into being a binomial square. The number that I got before I squared it is what the binomial is. So what was that number that we got before we squared it and got 25/9? 5/3. That's what goes in the binomial. The number that we got right before we squared it. Okay. So now we're going to have to do this math over here. Okay. Remember, with fractions, you have to get a common denominator. So what denominator do I need to have here? What does this bottom have to be? This has to be 9. So I have to change 8/3, and I need to make it something over 9. So what over 9? What's going to go on top?
24.
24. How'd you get that?
Multiply by 3.
Multiply by 3. So 24 ninths. Okay, so that's 24 ninths plus 25 ninths, which we can add those. All right, what do I get when I have 24 ninths plus 25 ninths?
49.
49 ninths. Okay, a lot of fractional work there. Okay, and for those of you who are kind of shaky with that, you should probably get good at using your calculator. Okay, so here we're at. All that work to get us there. Now, this is what I was saying, even though it kind of is ugly work to do as we work through the problem, what do I know about 49 and what do I know about 9?
They both are squares.
They're perfect squares, right? So when I go to square root both sides, the numbers are still going to turn out relatively nice, because that's my next move, is to square root both sides. All right. When I square root 49, I get 7. When I square root 9, I get 3. So this ends up being plus or minus 7/3. Okay, so that, like I said, even though I knew we were going to have to divide and introduce fractions, the fractions could be a lot worse. They turn out okay. All right, so then I subtract my 5/3 over, and this time I separated them out, because I know with fractions we get a little tripped up. So negative 5/3 plus 7/3, negative 5/3 minus 7/3. Okay, so what is this going to give me? This one right here. Negative 5/3 plus 7/3. What does that give me? Negative or positive? Positive 2/3. What about this one over here? What's it going to give me? What's on top here? Negative 12/3, which is negative 4. Okay. Now, both of these problems that I showed you came out nice. Okay. In your homework today, that's not going to happen. Sometimes you're going to be asked to put your answers as decimals like you did yesterday. But other times you're going to be putting them in simplified radical form. And we haven't really worked with radicals a lot yet. We worked with them a little bit. But I want to go through an example like that so you know how to leave them in simplified radical form without using a decimal. Now, I'm going to show you a problem that you did yesterday, okay, rather than going through the whole process again, because what I really want to focus on is the simplified radical form. So yesterday, this was number 15. You did this in your homework. It was the very first problem that you did. And yesterday, I had you convert the square root of 20 to a decimal. Today, that's going to happen for a few problems, but for other problems, you're actually going to leave it in a radical form. So I want to show you how to do that. Okay. So there's a couple things. One, I have to move the 3. Okay, just like yesterday, I have to add the 3 to the other side. 20 is not a perfect square. Does 20 have any factors that are perfect squares? Any numbers that go into 20, that's a perfect square. 4? 4 times what is 20? 5. So are there any other numbers, any bigger numbers than 4? Is 4 the biggest perfect square that goes into 20? I mean, does 5 have any factors besides 1 and 5? 5 is prime. So no, 4 is the biggest one. So here's what we're going to do. Okay, 1, I moved the 3 over, and now I'm going to think of this 20 as 4 times 5. And the reason that I do that is because I know that 4 is a perfect square. We can take the square root of 4. So what is the square root of 4? 2. So the 2 comes out. The 5 stays underneath. I can't do anything with that. So in terms of simplified radical form, this is what we're going to write. Okay? That's going to be my final answer. So when you're asked in your homework today to keep it in simplified radical form, that's what you do, and that's where you stop. Okay. If it asks to round to the nearest hundredth, now I changed some of the directions. So when you look at your Canvas assignment, I tell you which ones I want to be decimals, and I tell you which ones I want to be simplified radical form. But that is simplified radical form. Now, one of the things that can happen also is this number underneath the radical can be negative. So that's where the i's start coming in. Okay? And so that can happen as well.